Hi, and welcome to Quick Math. In this segment, we will be walking through three-dimensional objects, surface area, volume, nets of 3D shapes, and the Pythagoras Theorem. 3D objects are best thought as shapes with a surface and a height or thickness components. In math, you're often asked to identify the surface area and volume of 3D objects. I must add that the unit of measurement of an area should include a square, and that for a volume should include a cube. There are three terms that are commonly used to describe a 3D object. The face of a 3D object is the side of the object. The vertex, or vertices in plural, of a 3D object is the corner of the object. The edge of a 3D object is where the faces meet. For this segment, I shall only cover 6 of its fundamental shapes for how we get to its surface area and volume. The cuboid is represented by the length, width, and height components. I shall not be covering the cube separately, as it is a subset of the cuboid where all its three components are the same. The surface area of a cuboid is the sum of the area for all its 6 rectangular faces, and volume being the product of its length, width, and height components. The rectangular pyramid is also represented by its length, width, and height components. The height of the pyramid must be a perpendicular measure from its flat base to its last vertex that is not representing the base. The surface area of a rectangular pyramid is the sum of the area for its 1 rectangle and 4 triangular faces, and the volume of a rectangular pyramid is 1/3 of the product of its length, width, and height components. A regular triangular prism can be represented by just its length and width components. The surface area of a regular triangular prism is the sum of the area for its 3 rectangular and 2 triangular faces. Separately, the volume of a regular triangular prism is the half of the product of its length, width, and height components, where the height can be derived from its width component using the Pythagoras theorem. The cylinder is represented by its circular surface radius and height components. The surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h, and its volume being equal to pi r squared h. The cone is represented by its radius and height components. The surface area of the cone is the product of pi r and the sum of r with the slanted length of the cone. Separately, its volume is 1/3 pi r squared h. The sphere is purely represented by its radius component. Its surface area is equal to 4 pi r squared and its volume 4/3 pi r cubed. A net of a 3D shape is what the hollow 3D shape would look like when it's opened out flat. This page shows 11 possible nets for a cuboid. This page in turn shows the nets for a rectangular pyramid, a regular triangular prism, a cylinder, and a cone. And here's what the net of a sphere would look like. Before I get into tutorial questions, I want to revisit Pythagoras theorem for the various ways in which it could be expressed when solving a math problem. Here are some more fundamental combinations that you want to recognize. I've taken the liberty to put up a formula for the category of fundamental combinations that is common in school math. Now we are on to tutorial questions. Press the pause button now if you need more time. Question 1. Which of the nets below is not for a cube? should be the one at the top right. Tutorial question 2. Press the pause button now if you need more time. Which of the nets below is for a cone? It can only be the one where the circumference of the circle is touching the arc of the sector. It need not be exactly what is shown here. However, the circle must be touching a point somewhere along the arc, not its radius, not the sharp end of the sector. Tutorial question 3. When does the rectangular portion for the net of a cylinder become a square? The rectangular portion of a flattened cylinder will become a square when both its sides are equal. This is achieved when 2 pi r is equal to h. A simple rearrangement of the equation should see to r being equal to h over 2 pi. Tutorial question 4. Do press the pause button now if you need more time. My strawberry ice cream scoop sits perfectly at its midpoint in the cone. The scoop is 5 cm in diameter and has a total height of 15 cm. What is the volume under the surface of the combined 3D shape? The answer is 114.48 cm squared. This is how you get it. Start by identifying the radius of the sphere, which incidentally is also the radius of the cone. The radius is simply half of the given diameter. Next, you calculate the volume of the hemisphere, which is half from the formula of a standard sphere. Then you calculate the volume of the cone, noting that this is the height of the entire ice cream minus the radius of the strawberry ice cream scoop. Finally, you get to the final answer by summing the volume of the hemisphere with the volume of the cone. Tutorial question 5. Do press the pause button now if you need more time. A tall fish tank has a rectangular base of 120 cm by 160 cm and is 480 cm in height. How far apart are the circled corners of the said fish tank? The answer is 520 cm. This is how the math is done. You start by imagining a right-angled triangle with its hypotenuse C being the line joining the two circles. The base of this triangle A is then calculated using the Pythagoras formula from the tank base length and width components. With B being the height of the tank, you can apply Pythagoras formula again to get to the answer. That's all for our segment on three-dimensional objects, surface area, and volume. Do join us in our other segments of Quick Math if you found this useful.